Last time on Design Squad, the teams made machines to
turn this stuff into peanut butter.
for a women's cooperative in Haiti. Red team was caught between a rock and a hard place.
You can stand on this, but I want to have something to stand on, all right?
Blue team cranked out a victory. So their design went to Haiti.
I like it.
And that put Natasha in the lead for the college scholarship.
Tom, let's see. I don't know. I'm just gonna probably sit him out and then have a chat with him before he decides to do anything drastic again. Because that behavior last challenge is just, I don't know, to me, unacceptable.
We've got 2 days to get this straight. Got a challenge, just won't wait. Our eyes are on the prize. 2 engineers just set the date. Got this client, can't be late. Oh no, it's go time. Build it, test, fix it. Debug, nail it, kick it. Gotta get it off the ground. Stick around and you'll see what teamwork's supposed to mean. It's so key, Design Squad. Design Squad.
No, they don't want to have it.
All right, Design Squads. We're going to kick it up a notch this week. Come on over here and check out today's client.
Hi, I'm Michael Parkhurst, and I'm a professional soccer player for the New England Revolution. I was the 2005 Major League Soccer Rookie of the Year. I'm a defender. My job is to stop the attack of the opposing team, intercept, and clear the ball upfield. So passing is an important part of my game. And the only way to get better is to practice, practice, practice. And that's where you come in, Design Squads. Here's today's challenge. I want each of you to build an automatic soccer ball kicking machine to help me practice passing. Here are the specs. The machines must continually shoot balls at me with speed and accuracy. I'll field test the 2 machines at a Revolution practice. May the best machine win. Good luck, squads.
Pretty impressive, huh? Michael wants a machine that's going to help him practice passing. So you need to focus on making sure that your machines kick balls with speed and accuracy. Each member of the winning team gets 100 points. Do you guys have any questions?
Oh my gosh.
So cool. What's our shopping situation? You guys can use everything in the shop just like usual. And for anything else you guys need, 2 members of each team will be able to go shopping. It'll definitely give you guys a competitive advantage to be able to automatically feed balls into the kicking machine. So you should definitely design around that.
If you don't have any other questions, you guys ready to start brainstorming?
Let's get some balls.
All right.
Let's get this brainstorm going.
My initial idea, as soon as I saw the Revolution guys, was a wheel here and a wheel here. So when these wheels spin outward, it pulls the ball in and shoots it out.
The way that baseball feeders work is actually just 2 wheels spinning at a high speed.
Some pitching machines for like baseballs, for example, they have just 1 arm that has a cup on it. It's the slingshot effect. It launches the ball forward.
I mean, there's a lot of things. It's kind of like a catapult. Kind of like the automatic football things. You pretty much take it back, and it's kind of like a big lever arm with, you know, like a high coil spring on it. Yeah, that's just like a
pinball launcher.
Yeah, that's kind of like it.
I would picture like a metal rod and like a shoe on the end. How you can get something to go from this position to this position.
These little gears would push up against this lip here, and then it would hit the shoe.
So it's a kicker.
It's a kicker.
Yeah.
All right, so we have our shooter, our thrower, and our kicker.
Roller slash wheel, pinball, or kicker. It's one of those 3.
I'd suggest we look at what we have first.
So are we definitely on
So
this
look
one?
for motors and wheels.
Just look
for everything.
For everything. Oh, in the shop.
All right, so let's do that.
Grab these, put them in the shop before red team
right
gets
now.
them.
What?
There you go.
What else?
We only need 2.
If a motor's too expensive for our budget, we could always use our drills.
The drills wouldn't actually spin fast.
I have no idea what this is.
I think that's for your car windshield wipers.
You want to
this
take
is
that
the
just
motor.
in case?
Yeah, it's a motor.
Yeah, let's just take that
I
just
don't-
in case.
I mean, we haven't said that we've chosen one, but we've gotten all materials for one.
And do you want to do pros and cons of the idea? Or do you want to just call it?
I know what I like.
I know what I like also, but
I don't want to straddle two ideas the whole day. Because that's what I always end up doing.
So the roller is our team's plan A then.
Had a two-wheel design, just like what it'd be for a baseball feeder. But I think we're really gonna need to take our spin on this. No pun intended.
the two wheels right here, and it's turning in opposite directions, and then there'll be like a hopper in the back.
You can either change the direction, probably like almost like a tripod setup. So if you wanted to aim it high or aim it low, we could change the direction of that.
We want to be able to also shoot left, right, you know, in all sides, as well as moving up and down.
Let's pick an idea and go with it. Is this the most voted one design?
I guess so, yeah. Everyone agrees on it?
Yeah.
Yeah, all right.
Good.
Yeah, they have Tom. They can't possibly win.
Yes! Wow, we're trash talking already.
Guys, when I peeked my head into the blue room, I saw that they had the big wheels that I saw earlier today in the shop. So it's possible they could be doing a very similar design to ours, even though ours will be better.
I'm kind of nervous because the blue team has a very, very similar design to us, so it comes down to the smallest details, like whose works a little bit better than the others. Oh, it's gonna be so close, I think. Makes me kind of nervous.
Kim and I are gonna go shopping.
Yeah.
If you guys can start and try to make the
Structure of it? Yeah.
structure of it, see if you can make something so that you can angle it a little bit.
So you have these two, and they have to be spaced out evenly.
The soccer ball goes right in the middle, these are spinning.
Oh.
And it just,
Shopping list. Two motors.
Two monster motors.
Fat tires.
I can already see this coming along, and I'm psyched about it.
Krishan and I will go.
Yep, I'm ready to go to the store, guys.
Alright, what are we looking for?
Turntable bearings.
Oh, I think we should go with big.
I think we should go with small.
Both.
Let's go with both. We have chicken wire. It's $5. We'll get two.
Nice. I think that's the last thing we can do, the frame.
No, the frame is the first thing we should
No,
do.
because we don't know how big.
No, we do know how big. We just have to go by the ball. 3,000 RPM. We use for our dragsters, we can use here. We don't want to take out the soccer player's leg. We want to impress them, not kill them. We should also build a frame around it so it's supported on both sides of the wheels. 19 1/8.
Put, like, tires.
Tires. It's just about 10 inches or so.
Hey,
oh,
are we gonna be fine with the wheels we have, or do you want us to get other wheels?
What kind of wheels do we want?
10-inch diameter with tires that we can take the air out of.
10-inch diameters that with tires that we can take the air out of.
You can't take the air out of those ones?
No, we can't.
They want us to get these. 10-inch ones we can deflate.
All right.
Axles for the tires. That one works.
Yeah.
We just need to get some sort of tubing to put the balls in.
Right.
All right, so that-
Now, where are we gonna get tubing?
No!
That's what we've been looking for. This is tubular. Put him in the car.
We can use anything in the shop. Anything in the shop is ours to use. You want to hold this motor for me?
Yeah, I'm scared.
I mean like
I am
hold
scared.
the motor.
I'm scared.
Hold you to hold it.
I did hold it.
See that spark?
Yeah, I can see it. I can see it. I can feel it too.
Hold it tight.
I'm holding it tight. Oh, yeah, see? No. What was he thinking he wasn't
No,
thinking?
see, when you didn't hold it, we're testing because what we're gonna be doing is we're gonna be mounting these wheels on these motors and having them spin.
I think
and that will be propelling
two will
four
suffice.
batteries.
We're using all four.
Yes, because we want them all to go as fast as possible.
If speed is what they're looking for, Red Team should wire their batteries in series. That means the positive terminal of one battery connects to the negative terminal of another. The more batteries connected in series, the higher the voltage. And a higher voltage will make the motors go faster. So to hit maximum speed, Red Team should wire all four of their batteries in series.
It's gonna be about 161 feet per second.
109 miles an hour? A little too fast?
We're gonna be killing him.
We can just set up the basic structure. Right there.
Oh, you guys, I'm so happy to see you.
We got stuff.
Yeah. basically built the actual frame for everything.
The part that's with Tom right now is going to be attached right here on the 3 hinges, and it's going to be able to fold up and downward.
You're gonna put the rotating pad here.
Yeah.
So the top piece, you center it, it's gonna lay down like that. So, all right, we're ready to fly.
I'm working on the structure for the base of the shooter. So I built a little triangle structure. I'm gonna build another one. So this is the board for the shooter. The shooter's gonna be mounted on here.
Nice.
So we now have horizontal movement. This piece of wood is going to be right here, and everything else, which is the motors and the wheels and basically the rest of our design, is going to be mounted on this piece of wood, or a piece of wood similar to this. And it's going to turn, I'm going to put a little handle back and forth so that he can change the direction that the shot is being fired in. So right now I'm working on the vertical movement of the shooter. So I'm going to try and use hinges and put the shooter on here, and then you can move it up and down.
I like it. Why don't you like it?
We have no way to make this movement stay.
No. When you attach angle iron here, like one coming out of here, one coming out of here, and every time you move the angle, because there's already holes in it, you just have to put a bolt through it. And do that for both sides.
We have to figure out the angle that this thing actually moves at. Hey, it worked! Yay!
I want to get the tires in position so we can start nailing everything down.
We're basically just building a table and drilling a hole right here.
That's about 11 inches from the battery.
This is what when I had designed basically was motor, motor, wheel, wheel. Wow, it's smoking. The motor can be mounted right on top of this piece of wood, and then have the axle go right through here and hose clamp it tight. So that's our makeshift coupling basically.
A coupling is used to join two shafts together. But because Red Team's axle and motor shafts don't line up perfectly, they need a coupling that will bend easily and rotate the axle. That rubber hose should do the trick.
And when the motor runs, this will spin, thus propelling the soccer ball toward the fire.
The pipes that you cut for me, these, will go in here, and there'll be a tack weld to prevent this from moving, and then the axle will go in here, and that'll also be welded.
All right, here we have our 2 axles. Now instead of welding them right here, we're gonna braze them. Brazing is a lot like soldering, except it uses higher temperature and it's a lot stronger. And before we get to brazing, we have to clean both pieces so the braze actually sticks. This flex that I'm putting on will protect our rod and our tube from being contaminated as we heat it. It looks a lot easier on TV.
Like, at this point, like, I don't see, like, the actual pieces of it coming together.
We really need to get this done because, yeah, we have nothing completed yet.
Where's the bearing? Yeah, I'm feeling a lot of pressure about the time because we don't have a lot done and I just super glued my fingers together.
Time's up. Wrap it up, design squads.
I brazed the bearing on the wheel, and I also brazed our axle to the wheel, so that now the axle and the wheel are one. So what we're gonna do, I'm just gonna go cut the axle so that the chuck only goes to about right here.
Okay.
So I'm gonna cut the axle so that it fits into the chuck and so that the drill can lay down.
It's like a sandwich. Nut, washer, wheel, washer, nut.
Don't watch your wheel.
Put it on the right way. Like this.
Pretty good.
It doesn't shoot fast enough.
Guys, we're gonna try launching a ball.
You ready?
Move the drills closer. Well, you don't have to cut the whole thing in half. Just drill two more holes. Then put another piece of plywood over it and then drill a hole in that. I would just drill two more holes.
We have to do this now. Like, no time to waste to talk about it.
Why do we have to move both of the holes? Why don't we just move one?
I'm not arguing against you. I'm just saying, if you're gonna do it now. Let's just go right now. Move.
I don't get what
move.
you're saying, though.
Remember the idea that we had from before where we would cut it down the center and just kind of piece it back together again?
You?
What about that? Work. Do it.
We need a different way to
Stop or control the flow of our balls. I'm gonna go cut this into a few shapes just for testing purposes.
Hello, Blue Team.
How's it going?
What were you guys talking about?
For our hopper, we wanted to hook up a motor, so as
long
it's
and
spinning,
short.
it'll go. Ball goes, stop. A ball goes, and now another one stopped.
If we just have one notch inside a circle, that would release one ball every rotation, so it would slow down a lot more.
That's cool.
That will hog the ball.
That will hog the ball, exactly.
We're gonna use this motor right here to control the gate to open and close and let one ball out at a time.
You know what? I can actually place this right at the head of the whole unit.
Sure, as long as you can get it done like as fast as possible.
That's done then, isn't it? Isn't that right?
Yeah, it's pretty much done. This could be mounted right up on top over here. It'll just be half a circle, and by the time the half comes up, the ball will be able to just travel down. Then after about less than half a second or so, it'd shoot the other one.
So this is the motor that will spin our stopper. What's the next move?
From this direction, it looks like a cannon.
Put a ball in. It shouldn't be going.
No, now it's gonna wait. It's gonna wait till it just stopped. Why did it stop?
See, it's trying to push the balls up.
All right, go ahead.
No, go.
For Blue Team's gate to work, it must slide along the ball until it rolls into the notch. But if the gate isn't slippery enough, the ball will jam like this.
It's not working either. And we'll just throw some balls through right now and impress the other team.
All right, get the motor.
stop it.
No. It worked fine, but look, this is broken.
I know, because the wood block stopped it. All right, we can't
It was
test
bound
it.
to break anyway. It's like in the middle of nowhere.
Krishan, we got 10 minutes before we have to test our machine.
We have to figure out how we're gonna mount this.
Okay.
It worked. Oh,
It stopped on
You gotta
on that wedge.
Dude, cut that off.
If we lubed it, it would slide a little bit better. I get sunscreen. Not only is this lubed up, but it's not gonna get a sunburn now.
Yeah. Ooh, like butter.
I know, huh?
One ball. Oh no.
What if we use a different motor? Let's just mount this because this is our last effort. We don't have any time for anything else.
Hang on 1 second.
Are you prepared to?
No, hang on, okay? Yeesh.
It's not working.
You guys about ready to go? Ish.
Well, time's up. You guys got to start packing up. We're going to move it over to the field, okay?
You guys have a drill that's about.
Hey, Design Squad. Hey. You brought your client, Mike from the New England Revolution. Hey,
Yeah, nice to meet you.
Come over and check out Blue Team's machine.
All right.
I think you're really gonna like it. We have here our soccer ball driller, if you get the pun.
We try to get our machine as low to the ground as possible.
And it can swivel left and right, up and down as well.
So
All
you guys
right, we'll
ready
give
to
it a
test
shot.
that?
Yeah.
That's all right. You figure it out, Blue Team. We'll wait. The red team's loving it right now.
Okay.
That's how you stop
Now
it.
we'll do it without the hopper now.
We don't need to trash talk. We just, let that machine do the talking for us.
The trash talking is increasing here. All right, it looks like they got it going here. They got it cranking now. All right. They got it working after all.
Very good work.
You guys got some steep competition.
Oh yeah.
This is our high-velocity soccer ball shooter. Using 2 wheels at a very fast speed, squish the ball between them, and it fires it out. It also can be changed for speed depending on the voltage that you choose.
Wow.
And we have this unit here that right now it's a little bit fast, but it can be tweaked a little bit so that it can have a continuous flow of balls, or you can just take it off altogether and just have 1 ball at a time, somebody feeding it to you.
You can also change the horizontal and vertical position to give the defender some variation.
Wow, it looks great. It looks like you guys spent a lot of time on it.
You did.
Let's do it.
Back up a little bit.
Oh,
Probably
no.
to about this line.
Don't
right
don't
there.
listen to him.
Ready?
It's all right. Wow.
I guess it's accurate. You killed a professional soccer player.
He's not dead.
Points off. Points off.
Let me know when you're gonna put it on full throttle.
That was our machine.
That was awesome. It was great.
All right, why don't we huddle up and talk about which team deserves the 100 points?
Okay.
How about the blue team? What'd you think of their machine?
I think after they got over their, initial problems and they got the ball rolling, it worked out pretty well. They had the ball coming up a little higher than the red team, but if we're concentrating on passing, then, I kind of let the ball a little lower.
What did you think about the red team?
I liked how they got out of the gates quick. Unlike the blue team, they had, minor difficulties, and once they got it rolling, it seemed consistent. they were all coming to me rather than, you know, making me run all over the place. You know, if I'm working on my own, that's what I'd like. Even though it was a little hard, maybe they just forgot to tell me to back up. Unfortunately, only one can win though, right?
Yeah, that's right. Got the news.
Well, it was a really tough decision. Congratulations on building 2 great machines. I know you guys worked hard and it paid off. They were great. But in the end, I had to go with the red team. Sorry, I felt like their accuracy was a little better and they got it going from the get-go. So I'm sorry, Blue, you guys did great. Okay.
So after 7 challenges, Natasha is kicking it in the lead with 580 points. All right, Deanne, here's a new challenge. Describe the Design Squad website in 10 seconds. Go.
There are games, photos, new challenges, videos, quizzes, scoring updates.
Time's up.
Ugh, just go to pbskidsgo.org.
Hi, I'm Scott Keller. I'm a project engineer for Burton Snowboards, and I design snowboard bindings.
The snowboard binding attaches your foot to the snowboard. I'll get artwork from our industrial designers and try to recreate their design intent.
If you can think about like a snowboarder who maybe weighs 150 pounds going off 50-foot jump, when he lands, there's going to be a lot of force going through the binding into the board. So I have to do stress calculations to make sure that they're not going to break when that force goes through them. We have a set of tests that we'll run to make sure that they're strong enough, that they're not going to break.
We do this test in a freezer because snowboarding is done in the cold, and we'll just make sure that it can stand up to the life that we think it should have.
If you've got a good idea and you believe in it, just because it doesn't work the first time doesn't mean it's not going to work eventually. The sport's being pushed all the time, and so our job is to try to keep one step ahead of that.